All right, today we're diving into a technology that's teaching AI a brand new and, honestly, a common sense trick: how to look things up. It's called Retrieval Augmented Generation, or RAG for short. And believe me, it's making AI smarter, way more accurate, and a whole lot more useful for all of us.
So let me ask you this, because we've all been there. You ask a super powerful, super sophisticated AI a question, and it comes back with an answer that is so confidently wrong, it's almost funny. So what is going on here? Why do these incredibly brilliant models sometimes say such dumb things?
You know, this isn't just a funny little quirk. The consequences can be absolutely massive. I mean, get this. When Google first demoed its Bard AI, it made one factual error about the James Webb Space Telescope. Just one. That single mistake was a factor in a staggering $100 billion drop in the company's market value. The stakes for getting the facts right, they're incredibly high.
And this all points to a fundamental tension in modern AI, something you could call the LLM paradox. These models are, without a doubt, brilliant, but they're also deeply flawed in ways we really need to understand if we're going to fix them.
So where does a large language model even get its knowledge from?
Well, it's all baked right into its internal wiring. Billions of little numbers called parameters that basically represent all the patterns it learned during its training. This is what we call parametric knowledge. It's not like a library of facts it can browse. It's more like a static, frozen memory of how words and ideas are connected.
And when you rely only on that locked-in, static knowledge, you run into three huge problems. First, what's called a private data blind spot. It has no clue about your private files or internal company data. Second, there's a knowledge cutoff. Its information is literally frozen in time, getting more and more outdated with every passing day. And third, the one we all know and love, hallucinations, where the model just confidently makes stuff up out of thin air.
For a while, the go-to solution for these problems was kind of a brute force approach, a really expensive and difficult fix known as fine-tuning.
So what is fine-tuning? Well, it basically means taking one of those massive pre-trained models and then retraining it all over again, but on a much smaller, more specific set of data. The best analogy is this. Think of a new engineering grad. They have all this broad knowledge from school, right? But then they get specific on-the-job training to learn how their new company actually does things. You're teaching the generalist how to become a specialist.
But, and this is a really big but, this approach has some massive drawbacks. It is incredibly expensive, requiring just huge amounts of computing power and money. You need highly specialized AI engineers to even pull it off correctly. And the worst part? The second your information changes, say you launch a new product, you have to do the entire costly process all over again. It's just not a sustainable way to keep an AI up to date.
So if fine-tuning is the big, expensive, difficult option, what's the alternative? This is where a much more elegant, much more efficient solution comes into the picture. And that solution is RAG. Retrieval Augmented Generation, or RAG, was first dreamed up by researchers at Meta back in 2020. And the core idea is just brilliantly simple. It's this. Instead of trying to cram every piece of knowledge in the universe into the model, why not just give it the ability to look up the relevant info from an outside source right before it gives you an answer?
Honestly, the best way to think about it is with this analogy. A standard LLM is like a student taking a closed book exam. They can only rely on what they've managed to memorize. But an LLM that's using RAG, that's the same student in an open book exam. They can check their notes, look up the facts, and make absolutely sure their answer is correct.
You know, Ars Technica put it really well. They said RAG is all about blending the AI's language skills with a good old-fashioned document lookup process. It's a simple but, man, is it a powerful way to help these models stick to the facts.
Okay, so it sounds great in theory, right? An open book exam for AI. But how does it actually work in practice? Let's break down the mechanics. It's really just a four-step process.
So the whole process flows through four key stages. First, indexing, that's where all the knowledge gets prepared. Then, retrieval, where the right info is found. Third is augmentation, where it all gets combined. And finally, generation, where you get your answer. Let's walk through each one.
Okay, step one is indexing. This is all the prep work, and it happens behind the scenes. You take your knowledge base, all your company docs, articles, whatever, and you break it all down into smaller, manageable chunks. Then each of those chunks gets converted into a string of numbers, called an embedding, that basically captures its meaning. All of these embeddings get stored in a special kind of database called a vector database, which makes them super easy to search through later.
Next up is retrieval. And this happens in real time the moment you ask a question. Your question gets turned into one of those embeddings, and the system uses it to search that vector database. It instantly finds the chunks of text that are the closest match, meaning-wise, to what you're asking about.
Now, here is the secret sauce: augmentation. The system takes those relevant pieces of info it just found and literally pastes them together with your original question. What you get is a brand new, super detailed, context-rich prompt for the LLM to work with.
And that brings us to the final step, generation. This new, beefed-up prompt gets sent over to the LLM. Now, the model has everything it needs. It has your question, and it has the specific, relevant facts right there in front of it. So it generates an answer that is grounded in that context, ensuring the response is accurate and based on real data.
So this four-step process might seem kind of straightforward, but its implications are, well, they're profound. So why is this one elegant solution poised to change pretty much everything for the future of AI?
Well, when you put RAG head-to-head with fine-tuning, the advantages just jump right out at you. The cost, it plummets because you're just updating a database, not retraining a whole multi-billion parameter model. Your data freshness, it's always current because you can add new documents anytime you want. The risk of hallucination, it drops like a rock, and the overall technical lift to make it all happen is just way, way lower.
So let's just sum up the big wins here. RAG gives AI access to current, up-to-the-minute information. It slashes those pesky hallucinations by tying the answers to actual verifiable data. It's way cheaper and more nimble than constantly retraining a model, and this might be the most important one. It enables transparency. For the first time, the AI can actually cite its sources, showing you exactly where it got its information. That's a game changer.
But we've got to be clear about this. RAG is a massive leap forward, but it is not a silver bullet. It's not perfect. The model can still make mistakes. It might pull up a perfectly factual source, but totally misinterpret its context or its nuance. At the end of the day, the quality of the answer still really depends on the quality of the information it has to work with.
And that really leaves us with a fascinating question for the future, doesn't it? We've basically given our AIs an open book. We've taught them how to look things up. The next great challenge is teaching them true comprehension. So as we keep pushing forward, what do you think is the next frontier for building an AI that we can truly, genuinely trust?